In this episode of KubeFM, I'm joined by Frédéric Gaudet, who's senior engineer at BlaBlaCar. He recently wrote about a problem every Kubernetes team hits sooner or later: slow pod startups. In this episode, we dig into how his team used Istio to warm up pods before they hit production traffic, avoiding cold starts and stabilizing user experience. Along the way, Fred shares the design trade-offs, how sidecars can help smooth rollout strategies, and why observability was key to proving the approach worked. We're excited to partner with TestKube for today's episode. Testing applications in Kubernetes doesn't have to be complicated or slow. TestKube is your go-to platform for cloud-native continuous testing. With TestKube, you can effortlessly orchestrate, scale, and automate tests right within Kubernetes, catching issues early and deploying with confidence. Try it out today and see why engineering teams trust TestKube to keep their testing simple and scalable. Visit testkube.io to get started. Now let's get into the episode with Fred. Hi, Fred. Welcome to KubeFM. What 3 emerging Kubernetes tools are you keeping an eye on?
Hello, Bart. Happy to be here. So, 3 really interesting things for us regarding Kubernetes are all the updates around VPA. For example, we've got some issues to size daemon sets. It's always a mess. And with the latest promising updates around VPA, we should be able to have some different sizing configuration for our daemon sets. So better sizing. And also something we look closely is multi-cluster SIG. It's not really, we are not really a target for this one because we only run a couple of Kubernetes clusters. So we are, but in the future it could be a challenge for us. So I have a look in this area to see how we could embrace in the future multi-clustering. So that's 2, not 3, but
That's okay. 2 out of 3 ain't bad. For people who don't know you, what do you do and where do you work?
So I'm working for BlaBlaCar, which is a French company which offer travel mobility. So our base market is carpooling. So let's say you want to reach some really good place in Spain, and the guys wants to travel the same within his car, and he offers a seat in his own car, which allows to save CO2 because only one car travels with 2 people in it. So that's the base market of BlaBlaCar, and now we sell also bus tickets and more recently train tickets. We started in Spain with Istio and the other company, I don't remember. But so in this context, I'm part of the infrastructure team. So we deal with our Kubernetes platform, which is GKE. We are hosted in GCP. Service Mesh, Istio, we'll talk about it later. And all GCP components like load balancer, DNS, KMS, and everything.
And as someone who lives in Spain, I have used BlaBlaCar several times over the last few years. And like you said, it's a great way to meet people. You have plenty of time to talk, and it's a very comfortable way to get to places that might be more difficult in other forms of transportation. And then, as you also mentioned, being more eco-friendly by reducing CO2 impact. So yeah, that's exciting. And how did you get into cloud native?
Yeah, that's a good question. I've always been a Linux enthusiast since I was a student, but professionally, I started my cloud journey with OpenStack back 2014. So yeah, a decade ago, long time ago. And yeah, since then I changed some products. I used a lot of different products, but yeah, for the last 5 years, mostly Kubernetes and Istio.
Very good. And we also track content that's trending in the Kubernetes ecosystem. We have a monthly report that comes out where people can see what people are most interested in, what they're having the hardest time learning. You obviously have written articles, but how do you keep updated with the Kubernetes and cloud native ecosystem? Where are your go-to places? Where are the places that you go if you want to learn something new?
It changes over time depending on the subject. Usually, I read articles on platforms like LinkedIn or Medium. Some Substack. I also subscribe to some Substack newsletters. and also follow some the big tech blogs companies like Cloudflare or sometimes ago, a long time ago, I used to follow GitHub or even Dropbox tech blogs. They used to have really good tech blogs, but I'm not working anymore on that part, so I switched. But usually, and some individuals, like for example, for Istio, Ginny Song has a really good blogs. Uh, he's got really detailed articles and really picky. That's a really good source for me around Istio.
Fantastic. And if you could go back in time and share one career tip with your younger self, what would it be?
That's a tough question because it depends on everyone's personality. But I would advise one thing: work your soft skills. It may sound counterintuitive because we all evolve in a tech ecosystems, and the more techy, the more you expect to be better and recognized. But in my opinion, we are all good. Or so good tech people, we got lots around the place. And what makes the difference are the soft skills, in my opinion. See your ability to listen, to communicate, to share your work, work with people. That's to me makes the difference and allows you to improve your career path.
That's a really good point. And, I think listening is underrated. If you think about all the courses there are for public speaking, and I've given and continue to give courses on public speaking, but listening is so much more than just being quiet when someone else talks. It's understanding where is that information coming from? How can I pay attention to them? How can I ask questions? There are lots of different ways to listen. Has there been anything in your experience that you've done reading books, any techniques, any things like that?
Read books, yeah, or nothing very specific, but listening to people and understanding what are their issues and how can I help them to solve their issues. That's to me a key thing because sometimes I want to solve things, but it will have no impacts on the company or other team in the company, so it's not worth it. Even if the subject would be a really fancy thing I wanted to work on, no, forget it. How can I help people and how can I make their life better? That's to me that's key.
Starting with empathy. I really like that. That's great. Cool. Um, so as part of our monthly content discovery, we found an article that you wrote titled Warm Up Your Pods Using Istio. So we wanted to dive into this topic a little bit further with some questions. Before looking closer, more closely at the problem that you solved, could you give us some context about BlaBlaCar's infrastructure and the scale you're operating at?
Yeah. So BlaBlaCar, we operate medium, small size Kubernetes clusters. So we've got around 4,000 pods in production over roughly 100 nodes, split into clusters, into production clusters. We mainly use Java applications as microservices, which represents 1,500 services in production. Most of them are stateless, and we are using a lot Spot instances as well as GitOps principle, which means that we roll out often. As soon as you merge something on your branch in your code, you got a new Docker image build, and then a new rollout in production. As soon as Google reclaim a node instance, every pod on it are killed and spawn everywhere. So those two things makes our rollouts. It's very crucial for us to have smooth rollouts due to this ecosystem really moving.
And can I ask a bonus question? Since you mentioned that you're running stateless workloads, have you had any experience trying to run stateful workloads, perhaps with an operator?
Yes, we've got some stateful workloads, databases, some Elastic Kafkas. We let them on the node pool, which is not Spot instances. So it's more stable. They are only killed when GKE roll out the new data plane versions. And usually that's fine. Sometimes we have to do some tweaks, but most of the time it's okay. But they can't land in on spot instances. It's really too volatile.
Fair enough. Java applications are known for needing warm-up time when they start. Can you explain what happens when a new JVM-based pod comes online and why this causes problems?
So during the very first seconds of a Java application life, the first process, the first requests are slow because at the beginning the code is interpreted. It's not recompiled, it's bytecode, and it's interpreted. So by definition, it's slow. And then the JIT, the just-in-time compiler, kicks in and compiles the code, optimize it using profiling, and all of this takes time, consumes CPU power, which means the workload doesn't have all the power it will need to process HTTP request and process normally what he has to do. So once this is done, the execution is much faster and everything is smooth and life is beautiful. But at startup time, the request latency is really bad. So this is only happening during boot time. It takes 1 minute, maybe 1 minute and a half. It depends, of course, of your CPU power on nodes, but usually this is an order of magnitude. And then it's okay. We notified this issue many years ago, but it has not really been prioritized, and so it takes us some time to tackle it.
And before finding the Istio solution, you tried several approaches that didn't work out. What were some of these attempts and what made them unsuitable?
Yeah, we tried, we investigate first and we identified several potential solutions, but we didn't try all of them. Technically, I mean, for example, GraalVM or CRaC, I don't know how you spell it, but yeah. But those two projects are interesting, but in a Kubernetes context, we find them really complicated to set up, especially CRaC, which perform a snapshot of your Java application, takes a memory image. So we will need to move the memory image on another node, or maybe stick the pods on the node where the image lives. So it sounds quite hard to maintain and operate at scale. So we push those two away. And we had two other potential solutions. The first one is the most obvious, is to give more CPU power to your application. We could say, okay, if it needs more CPU power to start up and start faster, give more CPU power, that's cool. But it's costly. It represents a waste of money because this is only needed during startup, but during application life, it's not needed anymore. But once it's reserved by the Kubernetes scheduler, it's reserved, and we can't reuse this CPU for other applications. So not really ideal. We tend to pack the pods on nodes, so we don't waste CPU power. I mean, that's our policy. So it didn't fit. And the other one was to create a startup container. So specifically, it's an init container which warm up specific endpoints of the application. It was okay-ish, I would say, but it came with many drawbacks. First, this is a tool to maintain. So this is the code. So we have to update it. It's also an init container, so we had to add requests. So it consumes resources, right? It's also something we had to configure. It means the developer has to declare the endpoint he wants to warm up. Maybe to remove endpoints which are deprecated and we want to remove. So it's a toy. It's something he has to maintain. And usually developers, they want to focus on their own application and not really how to warm up the application. So creates a kind of friction. And finally, we couldn't warm up all post endpoints. It was really a main drawback. We could only perform some simple GET requests to warm up the application, but everything which has a context due to interaction with a user, like post, it was complicated to do. So we missed half of the target. It was toy, maintenance, so not ideal. And then Istio came. It came in 2024, I guess, something like that, in Istio 1.18. So it was the first release of the slow start mode from Istio, which only had at the time one parameter, the duration window time. So what it did, once the pod starts, it receives only a fraction of the traffic during a time window, which the developer could set up 1 minute, 2 minutes. And then the traffic increased slowly until it reached this time. We were pretty excited to test it when it was released, but it quickly turned out that the initial percentage of traffic was already too high for us. We had a service with around 2,000 requests per second, or something like that. And we already had really a lot of slow requests, which breaks our SLOs. So yeah, wasn't ideal. So I dig in the documentation and check how could I improve the thing. So I know that Istio is based on Envoy. So Istio API exposed some portions of Envoy API, but I discovered that Envoy had everything I wanted to. In addition to this time window parameter, we had two other really interesting parameters, which was the minimum percentage of traffic, and the second one, this is the curve, how the ramp up, what is the profile of the ramp up to reach the 100% traffic. So yeah, I was wondering how could I integrate those two parameters in the Istio API, since it exists in Envoy API. And that's when we decided to contribute that stream.
And what exactly did you add to make the warm-up configuration more flexible?
Simple thing, in fact. So Istio has two main repositories. The first one is the API, which is mostly protobuf definitions and CRDs. Okay. And the second one is the repo, the code by itself. So I made a first contribution to the API to update the API to include the parameters we had from Envoy and deprecate the other one. And the second pull request to implement the API modification I've made in the API repository. So 2 steps. If someone is interested to do it, I would advise to really prepare those 2 pull requests in a row, because as soon as the API has been updated, the CI breaks in Istio if you don't implement API test. So that's why I experimented last year. I thought, okay, I'll do it later. And I realized that every contributor in this repo were stuck. And I was like, oh my God. I had to rush a little bit.
So the aggression parameter introduces nonlinear traffic scaling. How does this work, and when would teams want to adjust it?
Yeah. So this is the kind of the curve to ramp up the traffic from 0 to 100%. So it could be a line over time. So it's traffic over time basis scale. It could be also from polynomial to exponential curve. To be honest, we stick with a linear one. because in fact, we would prefer a reverse curve, which really is slower and then increase, instead of an exponential one, which is really with a really high curve and then smoother as soon as you reach the window. Because our concern is we want to have the minimum traffic to warm up the pods. So the really minimum right now with the setting we've got is this is a line. So we don't really use anything else.
You conducted extensive testing with Fortio before production. What scenarios did you test, and what surprised you in the results?
So I tested all the scenarios we got in our cluster, which fits with what happened in our production cluster: traffic spike, rolling out, getting killed at any time. So that's why I'm conducting those tests. Regarding rollout strategies, it wasn't really a discovery for us because we used on by default max surge or max available or max unavailable rolling out strategies in our deployment. But I was curious to see how the warm-up would behave with different parameters. So it was mostly curiosity for me. And I had in mind to write an article at the time. So I thought it could be interesting for everyone else, even if they don't use it, especially if they don't use those kind of parameters. And that's why I highlighted that in the article. And I was also curious to check the relationship with the HPA, because when a pod rollouts and gets a slow ramp up, it means that the share of the traffic of this specific pod is split over the other pods, which means the other pods get more requests than usual. So at scale, it's okay. It doesn't really trigger the HPA. It takes some 5 minutes for the HPA to trigger on a pod. So if you set up your warm up to 2 minutes, your pod will have a little bump, a little CPU overload, but it doesn't really trigger a new pod, a new HPA, which will also have a small ramp up and everything. So it could be unstable. So keep your warm up under your HPA settings, and that's fine.
And speaking of deployment strategies, you found that Kubernetes rollout settings significantly impact warm-up effectiveness. What's the relationship there?
The relationship is without any strategies, all the pods are killed at the same time, which means that the traffic share calculation can't be accurate because basically we don't have any pod remaining in the cluster. So it doesn't work at all, and all pods would receive the same amount of traffic from start, which is really what we don't want with the warm-up. So this is crucial to have rolling out strategies with either max unavailable or max available, mean available. It doesn't matter, but the strategy is mandatory to have a proper working warm-up configuration. Otherwise, it's worthless.
And so when you deployed this to production, what kind of improvements did you see in your service level objectives?
It was really, really good. Especially we conducted this first test on a specific endpoint. I didn't really mention it in the article. I mean, I wasn't so specific, but this endpoint it's a moderation service. If the moderation service doesn't answer fast enough, the message goes through and is delivered, which is not what we want. We want to moderate all the messages and protect our user from scammers. And before the warm-up, I won't say the detail, but a lot of messages could go through has been delivered without going through the moderation service. I don't mean it's all scams, but we knew that a lot of messaging weren't moderated. And passing after this improvement, it's only a really small fraction of messages which are delivered unmoderated, but really small. So the improvement was huge technically, but for our users, it's way better. So yeah, it was cool.
And you mentioned this doesn't completely eliminate slow requests. What are the remaining limitations, and why is this solution still worthwhile?
Yes, indeed, the very first requests are still slow because even if the pod is still cold at the beginning, so it doesn't receive as much traffic as before, but it still receives a share. So the very first requests are still slow, and this is really assumed by our product managers. As soon as we stick to our SLO. Our SLOs are it's our compass, our targets, and if we are in the line, that's fine. And if we don't, we'll find another solution. But that's something everyone is aware in the company. That's we are not 100% perfect on this area, and that's the objective of SLOs. That's the right balance between being reliable and effective with a reasonable cost and reasonable toil. That's something which is okay for us right now.
And for teams wanting to implement Istio warmup, how should they approach setting the 3 parameters for their specific services?
It's very simple because it's only a couple of parameters. So the first one is to define the duration window. So check your HPA first and just pick your number just below. Between 1 and 2 minutes should be okay. Regarding the curve, we stick with 1, meaning the linear one, which gives already a good results. But if people want to iterate, they could start with this one and then try some other curves and check if it's better or not.
This seems like a relatively simple configuration change that had massive impact. What made this solution particularly elegant compared to the other approaches that might be out there?
Yes, it's simple, and sometimes simple solutions are really very nice. Yeah, it's like any tool, we have trade-off to make, and the warm-up wasn't so great because, as I said, because it's code to maintain. It's waste resources, and plus the developer has to configure something. This one, it just works out of the box. Only a couple of parameters. The default are really good for everyone. We don't tweak any particular services regarding this warm-up. We have it by default for every Java application in BlaBlaCar with the same settings. So you have no maintenance, no code to maintain, and people tend to forget it at the end. That's perfect for infrastructure guys like me. That's really cool when developers just forget they're running on a service mesh.
Now, looking back at this journey, what advice would you give to other teams that are facing similar challenges with service warmup during deployments?
I would advise to when they face some issue like this is to really qualify the problem and don't forget that the service mesh could be potentially the best candidate to solve a problem like that. And that's I think the issue, the problem we had with the warm-up. We found developing solutions to an infrastructure problem, and that's overload the code and it missed part of the target. So picture the world problem, face all the solutions possible, discuss with different people in the company, developers, DevOps, infrastructure engineers, and then try to figure out the solution and the right target to go.
Now, with that in mind, we do, for the folks that are watching, you'll see that Fred has a guitar behind him. If you're listening, you won't, but I'm telling you, there is one. when we think about the problem of learning the guitar, walk me through your experience of when you started playing guitar, the challenges that you faced when doing that.
To me, it's the main problem was to really have a good knowledge of the neck, because without a good knowledge of the neck, you can't improvise. You can't really be autonomous and let just your brain think about the music and your fingers follows. So when you don't have this comprehensive neck, you have to think about it, and then your brain is focused on your techniques and not on the music. So
Very good. How long have you been playing guitar?
20 years ago or something.
Yeah, I'm about the same actually. Yeah, pretty much the same. And what was that process like? Did you take lessons? Did you study in a more formal way, or how was your learning process?
Oh, first I've made everything. I started just on my own. Then I took lesson when I was a student studying jazz guitar and music theory and everything. Then I stopped 10 years because I had kids and was focused on something else. And now my kids are a little bit higher, they're older, so I have more time. And the last 6 years, I started again, take lessons in music schools and play with band around the place.
Very cool. What kind of music are you playing in your band?
Oh, I used to play funk for a couple of years. It's like James Brown, Maceo Parker, Tower of Power. It's really hard to play with horns and everything. So I've made that 3 years, and now I'm more about composing music with my band, and we compose pop rock music.
Very cool. If we want to check that music out, is there anywhere we can see it or listen to it, I should say?
We record some stuff in SoundCloud, but I think this is private, right? I have to ask my mates if there. But yeah, we've got three. We got 3 of them.
Okay. If you decide to open source some of your music and share it so we can listen to it and enjoy it, that'd be great. But I also understand. I think it's really cool, like I said, is that seeing the parallels in the learning journey, the getting resources, the troubleshooting aspects. And because in my case also, I started out learning on my own and then took lessons, but mostly have done things on my own. I do agree with the understanding of if you don't map out the neck and know where all the notes are, it's going to be pretty difficult to play the notes that you want to play. And I often think as well too that I've learned a lot. Guitar has taught me a lot about that making mistakes. It's not something personal; it's an opportunity. And oftentimes you'll make a mistake and realize, oh, I really like that mistake. I'm going to keep making it. Now I can sound more like Catfish Collins or whatever guitarist that I want to emulate. So I think there's a lot that you can learn from that, and I think can be applied just about anywhere. Now, my last question is, why a Les Paul and not a Fender Stratocaster?
Because I also have a Fender Stratocaster.
I just can't see it. That's good.
It's just on the other wall.
Oh, it's on the other side of the camera. Okay, that's it. That's good to know. That's good to know. Okay, cool. So you appreciate different guitars that provide different sounds. A couple of our listeners, Emin and Orlin, are also really into playing guitar, and we often talk about it. So it's a pleasure to be able to speak about this in a podcast recording. Well, Fred, what's next for you? What are you going to be doing next? Are you going to be writing more articles? Are you going to be exploring more elements of Istio? What do you want to do?
Good questions. Yes, I don't have any article on the way. But yeah, regarding Istio, I would like to work more on multi-mesh. It's multi-mesh settings. Because right now we've got several meshes in different clusters. It's always a multi-cluster ID, and all the security between meshes are pretty much are not ideal. I would like to improve that with more request authentication, authorization policy, and east-west gateways between meshes, so that it could smooth the communication between clusters and improve the security. So I would work on that in the coming months.
Fantastic. And how can people get in touch with you?
LinkedIn, that's a really nice way, or even my email, frederic.gaudet@blablacar.com. That's it. It's simple.
Yeah, LinkedIn worked for us, so I could definitely speak to that. Fred, thanks so much for sharing your time and your knowledge with us. Really enjoyed speaking to you and look forward to talking to you in the future. Take care.
Bye-bye. Thank you.